Hey guys, it's often said that good features are what make or breaks a model's performance. So here we are talking about missing data and imputation. The process of replacing missing data with statistical estimates of missing values is known as imputation. We have started a new series, a playlist of videos to understand everything about feature engineering. We have already seen basics of feature engineering in the last video. So if you're coming here directly, I urge you to watch that video first. I'll keep the link in the description and in the I button above. If you are new here, I'm a mentor in the field of AI and machine learning. Started my journey long back 12 years before as a mentor, and during this time I got exposure to multiple technologies from Java to DevOps to Python to data science and also to AI. I have been helping corporates understand and implement applications, especially in Python, data science and AI. It's often said that good features are what makes or breaks a model performance. So in this video, we will deep dive and understand how to perform data cleaning and different imputation techniques practically. We are going to understand their impact on machine learning model, and we are going to implement the same imputation techniques in pandas, sci-kit-learn using Jupyter Notebook. So stay tuned and make sure to watch this video till the end, and let's get started. Hey guys, welcome to AI with AI. This side Asif Imnat. So this is the data given by the researchers. Where do the data scientists spend most of their time? If you see, most of the time, 50 to 60% of the time, efforts are spent on cleaning and organizing data, and very less efforts are required for training, for refining algorithms and so on and so forth. So quality data is what really matters to build the successful machine learning model. In the previous video, I also discussed about the different steps which are involved in feature engineering, right? There are basically 5 main steps which are involved: data cleaning, data transformation, feature extraction, feature selection, feature iteration. We're going to talk about these one by one in the future videos. Currently, we are on first, that is data cleaning and imputation technique. This is what we are going to talk about, and we'll implement it practically using Jupyter Notebook. So what do you mean by imputation? The goal of any imputation technique is to generate a complete data set. Basically, wherever you see NAs, NANs or incomplete data, we need to impute. We need to add a sensible data so that can be used to train machine learning models. And what are the different imputation techniques that we have? Let me talk about that quickly. So as you see in the diagram, we have two ways: statistics imputation and arbitrary imputation. So statistics is the most famous one and generally used. And for statistics imputation, we use mean, median or mode. Mean, median is mainly used for numerical values, and mode is generally used for categorical variables. Wherever we have numbers, numerical values, we use mean or median, and wherever you see characters, categorical variables, we use mode, right? So if you have missing data in some of the rows for some of the columns, then we should add some sensible data, and we are using statistical way, and also we can use arbitrary way, but statistics makes more sense to impute the data. So if you don't know when to use mean, median or mode, let me quickly talk about this in a short and we'll jump for the demo, right? So mean, median, mode. When to use mean, when to use median, when to use mode. Mean and median is nothing but averaging. So mean is best used when data distribution is symmetrical. As you see in the middle, this is data distribution, and you see it is symmetrical and there are no clear outliers. Data is not biased. Data is not asymmetric. So here mean fits best. So if data is not skewed, data is symmetric, I go for mean. I prefer mean. And if I see data is negatively skewed or positively skewed, I prefer using median. When data distribution is not symmetric and I see a clear outliers here. So whenever I get a data, I always practice to plot the data so that I understand the characteristics of data. I understand the distribution of the data, right? So based on that, I will decide whether I would impute mean, median or mode. Mode is simple. We use mode for categorical data, for characters, right? The question is only about mean or median. I hope that's clear now. Now let's jump to the Jupyter Notebook and see how we can perform the same. Alright, so here I am. This is the same repository which I have also uploaded to Git repository. The link of all the code, all the implementations that I am using here for the demo are kept in the pinned comment and also in the description. Please find that out. You can copy paste the same thing and try on your own. So I'm going to folder 0. Basically this comes before all the machine learning algorithms. So this is feature engineering. So I'll go to feature engineering, and we have already seen missing data. We have seen creating new features. Now I'm talking about mean, median, median imputation. Let me open this notebook. In this notebook, our goal is to handle missing data using mean, median and mode, right? So I'm gonna import pandas, matplotlib to plot some data, and train test split to split my data into training and testing, right? Shift enter to execute this. Then I'm gonna select some of the columns. The columns which I'm selecting are basically from house price.csv. So we're using a very famous dataset here, which is housing price prediction dataset, and specifically we are using some columns on which we want to perform imputation. And I'm reading house price.csv. Basically this is available within the dataset. Let me show you where I have kept this CSV file. Okay, under this feature engineering, you should see mean, median, imputation Jupyter notebook, and under data I have house price.csv. This is the dataset CSV file that we are using for feature engineering. Let me come back to the Jupyter notebook and execute these cells. Let me select the columns. Let me load the dataset and also print the dataset head. Okay, so I have 1460 rows and 10 columns now. So you see lot frontage, overall call. These are different columns which are available, and this is how the dataset look like. Remember that we have 1460 rows. We are using mean or median that we will use to replace NA, which are calculated on the training dataset. Let me proceed, and what we are doing here, we are preparing our data xtrain, xtest, ytrain, ytest. We are splitting our data into 30-70. Test data is 30% and 70% is training data, right? We don't want to consider a sales price for now, so we are dropping that column and random state 0, and let's print the data. Let's see how it looks like. So out of 1460 rows, now I have 1020 training rows and 438 testing rows, right? 9 columns because I dropped 1 column. Sales price I don't want to consider. This is our Y column, which is basically a prediction. Okay, that's why we dropped it. Let's start with finding the missing data. So to find the missing data, I'm simply using training data, and if it is null, show me the mean of this. So here I see a fraction numbers. That means wherever I have null, these values will return fractions. So this column also has fractional values. That means these columns contain some nans or nas. So let me capture these variables, I mean these features, columns, wherever I have null values, and I'm gonna do that by using a simple for loop here. I'm checking the condition. If the variable value is null and their sum is greater than 0, that means it will return fractional number, and that means these are the variables which contains null values. So let me print these variables which contains null values. So I see the output here. So these are the same columns which I see here as well, right? Now let me print the distribution, that is histograms, so that I can understand the characteristics of data. You know, whenever I get the data, plot the data. That will help you understand the insight and help you decide whether you want to use mean, median or mode. Okay, before we proceed and discuss in detail, if you are new here, don't forget to hit that subscribe button and the bell icon so that you won't miss our latest videos on AI. We see you are watching our videos, but 90% are not yet subscribed. We put a lot of efforts creating these videos for you free. Keep us motivated by liking and subscribing, so YouTube algorithm will also help us reach more audience. So did you subscribe and like? Thank you. So the distributions that I see here shows some variance, right? So for this column, I see some range. So it is between 0 to 120. So this histogram here shows me if I have to use mean, median or mode. Mode for sure, we won't be using it for numerical values. If I see for lot frontage, I see data is skewed. It is not symmetrical data. Lot of variations. So I might use median for this, and also for mass area, I see lot of values which contains 0 and high variance, highly skewed for other numbers, right? So I will definitely use median for this. And furthermore, also here for garage and for wood deck, for these columns also we should think of using median. Whereas for this column, I can think of using mean, right? We discussed it already, right? When to use mean and when to use median. Now all I need to do is capture the median of these 3 variables, 3 columns which we considered above. I'm gonna consider xtrain and variables to impute, basically the columns where we are gonna use imputation, and using simple median function here and converting it to a dictionary. So in return, I'm getting a variables of dictionary for each type. So these are the median values for lot frontage, median value for mass 1 area, and garage, whatever the column is, this is the median value, right? Now we want to add these median values in the data set. How do I do that? To do that, I will replace missing data by simply using one function, which is fill_na. Extrain fill_na, and this is the dictionary where we have captured the median value which we want to replace. And I want to do it in the same data set. I don't want to create a new data set. So in place true stands for do it in the same place in the same data set. Okay, so let me execute that. Now let me quickly check, and if I'm getting sum as 0 and no fractional values, that means I do not have any NAs or NANs or missing data here. I can do the same for test data and see there are no missing values. Now if you want to impute mean, all you need to do is replace median with the mean function here. All the remaining code remains absolutely same, no change. Replace median with the mean, and that's it. Okay, now let me talk about quickly how do I handle imputation for categorical data, for characters, right? And for characters, you know that I'm gonna use mode. So these are the columns to consider, because I know that these are the columns where I have categorical data. Again, I'm loading the house price prediction, same data set here. Let me execute these columns. And if I print the head, you see that for this column, we have characters, right? Categorical data. So this is where I can think of using mode and not mean and median. Nothing different, same thing again. Let's separate training and testing data set. I'm dividing into 70-30 ratio. We are dropping sales price. We are considering only these two columns, because only for these two columns I want to identify mode. Let me execute this. So now I have train and test data set ready. I will just check if I have any nulls here and identify the mean of these. And when I look at the mean, I'm getting a fractional values. I'm not getting 0. That means I have missing data in both the columns. Now all I need to do is capture the imputation values. Basically, what do you want to impute wherever you have missing values? So wherever I have missing values, I'm gonna use missing. So we have created imputation dictionary, and I'm gonna embed missing wherever I have missing data. So this dictionary is ready. This is how it looks. Simply I'm gonna use fill_na function. Wherever you have missing values, impute this dictionary, meaning add missing variable in the same place. No need to create a new data set. Do it for train and do it for test. Let me execute, and now let me check the sum. If sum is 0, that means now I do not have any missing data. I do not have any missing values. Same goes for null and same goes for test. I'm just checking xtrain is null just to verify do I have any null values. It will return boolean, so I see false, 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 everywhere false. This means I do not have any missing values in the data set now. This is how we can impute mean, median and mode in my dataset. So this is very simple. We understood how to clean the data and perform the data imputation, different ways to perform the imputation. We encourage you to do more experiments with the feature engineering to see how it can improve the performance of your machine learning model. That's how we come to an end of this video. If you have any questions regarding the same, let us know in the comment below. If you found this video helpful, please subscribe to my channel and hit that like button. Don't forget to share this video with the friends and the colleagues. Thanks for watching. See you again next time. Till then, take care and bye-bye.